Hey, what's up? So today I'm in the project labs. I've been here for like 7 hours. I'm pretty exhausted, but I actually wanted to give you like an update on my final year project and a number of the prototypes that I've been working on. So the final system for my project is supposed to do real-time, I actually don't know if real-time was a spec. Anyway, hand gesture control of a virtual object in augmented reality. So being able to reach into a scene and move a virtual object around. That is the intention of my project. And so I've been building a number of prototypes and a number of small systems that are hopefully, when combined together, going to be able to achieve this at the end of the year. So today I'm going to go through like one or two of those prototypes and just talk you through some of the design and like testing process behind actually building them. And yeah, I'll show you. So to start off with, I have this notebook that I've been keeping here with a bunch of just notes about the project and about different like things I've been trying to get certain stuff working, like how to get the hand tracking working, to-do lists, different ways of rendering my cube, because I'm going to be using a cube as my virtual object in the scene, which you're going to be able to pick up and move around on the desk. So different ways of rendering the cube using OpenGL or OpenCV, different ways of putting like setting up the cameras and that, different ways of basically generating region proposals across the image to detect whether or not a hand is there, and then summing the pixels of those regions. The color pixels, you'll see later in the prototype. And yeah, basically just a whole lot of thoughts and that about the neural networks and about the thought processes behind the project. Then over here on my computer, okay, so I'll show you this prototype first because it's one of the coolest, and it's basically using a bunch of the different prototypes all together to create like a kind of integrated working prototype. So basically what's happening here is in the background a TensorFlow model is running to determine whether or not my hand is in an opened or closed fist position, and based on that the object either tracks to the location of my hand or not. And so right now you can see moving my hand around, but then when I go and grab the object and make a fist, then it tracks to my hand. And you can see it's a bit buggy and it's not that accurate because I've only trained the neural network with a little bit of data. I need to do some data augmentation and improve the neural network's performance. But yeah, basically when I let go, virtual objects, stay away. The object stays away. And yeah, this is using an OpenGL rendered cube because drawing it from scratch seems like too much work. I've actually been investigating doing it with OpenCV, but for now, OpenGL. But yeah, grab a virtual object, move it around. It's a cool little prototype, and it shows all the work that still has to be done, but also a lot of the progress in moving the virtual object around and doing the kind of hand tracking in the background. Let me stop this in the background. People are testing antennas and that in the lab, so it's been noisy recently. But that system that you just saw there with the hand tracking actually uses a first principles hand tracking algorithm, and that hand tracking algorithm makes clever use actually of the YCVCR color space. So normal color space that we all used to is RGB, red, green and blue pixels combined to make any color that you can think of. But there are alternative color spaces that you can use in computing to represent different parts of the image with different information. And so the YCVCR color space uses, and I think it's a illuminance and then two chrominance components for blue and red respectively, and how light they are. And human skin has a particular tone or a particular hue in that color band that can be filtered out for, and so you can segment human skin out from the background. So that's what's happening in this hand tracking software here. You can see all the rest of the background and the rest of the desk and that, because it's coming from this webcam right here, is being segmented out, and it's finding the largest concentration of skin-colored pixels in the frame and then tracking them around. And in this way I've built a pretty decent hand classifier, or hand tracker rather, if I do say so myself. It occasionally gets confused by the size of my forearm here at the top, but that's kind of fine tweaking, and that can be done closer to the demo. But yeah, when I'm sitting here at the desk working my hand around, it extracts in the top left corner of the screen here the hand from the background really well, and that's going to be really useful actually for later stage of inputting to the neural network, and that you don't want to input a lot of noisy background data that's unnecessary for your classification. And so if I can crop the hand and feed it into the neural network, that's going to save a lot of complexity and training data and pain and suffering. And yeah, this is my hand tracking application. This is the most impressive thing I've done so far in the project, and I'm really proud of it. And yeah, combining this with a nice neural network afterwards is going to give me my whole pipeline for the control of the virtual object. The other main part of the project is obviously like the virtual object, which I've shown you rendered using OpenGL, but using and interacting with that virtual object in the context of a real environment. So being able to manipulate that virtual object in relation to other real-world environments. Other real-world objects. If there's another, like say, real-world item on the desk like this, will you be able to push the virtual object through it, or should it behave as it should, as a real object? You try and push a virtual object through here, and then it gets stuck, and you have to go around it. So that's what the Kinect sensor is for, and the Kinect sensor is basically, it gives RGB and depth values, but what I've been doing at the moment, sorry, let me just get it up and running here. I'm not going to show you any demonstrations, because in the background it's just a giant matrix of values, those depth values. But what I can show you is the depth information that I'm using in the background to do collision avoidance. So right here you can see, where's the Kinect sensor? It's over here. When I am a certain distance away from the Kinect sensor, it gives a certain depth value, and that's colored in red. And then when I move further away, it goes to yellow and then to green. And using that depth data, I'm going to be able to determine whether a virtual object has collided with a real-world object, and then maneuver things around like that. Yeah, this is one of the parts of the project that still needs a lot of work in the next month before I start writing the report and focusing on like the demonstration. But yeah, this is basically the depth data. This is what the Kinect sees, and this is kind of what's going on in some of the background of some of my collision detection algorithms, which are in very early prototype stages. I've got one at the moment where you can like push your hand, and then at a certain stage it just stops, but it doesn't actually detect any objects if they're there. I've just set like a hard boundary, so I need to work on that a bit more. And then, what else do I have to show you? I have this, remember I talked about my OpenCV cube as opposed to my OpenGL cube. OpenGL is a proper 3D rendering library, but I was struggling with some of the perspective, because OpenGL works with a kind of perspective-based rendering algorithm where the object sits in the middle and you just move a camera around it, whereas like OpenCV and the Kinect and all of these work on like an XY grid system, and then you want to move the object around in that grid. And so I experimented just drawing cubes with like lines and some maths, but it's not going so well, and so this is just an idea, and I might use it in my final demonstration, I might not, depending on how the integration goes a bit later in the semester. And obviously I mentioned earlier that I was using TensorFlow to build my neural network, but that's just for the testing and training stage, that I can use TensorFlow's optimized backpropagation process. But what I'll actually be using in the final implementation is my own neural network, which is going to be slow as fuck. But that's what this thing over here is. So this here is my very own neural network that I've coded up and built using NumPy. And basically it does all of the convolution and all of the matrix multiplication in the background, using the weights and that are going to be generated from the TensorFlow implementation. And so I've kind of designed it off of Keras, the TensorFlow library, but basically with different classes for the different layers available for use in the neural network. So input layers, convolution layers, max pooling layers, flattened layers, normal hidden layers for fully connected network, and then an output layer. And in each one of these different classes of layers, which you can use later on when you define your network, what is it? Over here, like I can say I want a convolution layer, well, that is 20 filters wide. This is the size of the filter, 3 by 3 by 1, 2,000 hidden neurons. All of these things then go in and inside of the classes here do all of the forward propagation and the backwards propagation maths for those, oh goodness gracious, for those relevant layers. And it was quite a lot of work to get this working. This is what I spent most of the holiday on, actually, just getting the forward propagation and backward propagation working from kind of first principles, because everything needs to be from first principles. Basically, at the end of the project, the only things you're allowed to use libraries for are what you spec'd for using libraries in the original proposal. And for me, that's just like the 3D rendering. And so yeah, this is it's a very slow implementation, but it's really helped me understand properly how neural networks work, and I might make a whole video about this in the future, how I built my own like neural network class, because it's very interesting, and I hear that's how to understand neural networks and machine learning properly, is to go into like the real depth of the maths and that, and understand the calculus. And yeah, I've spent a lot of time working on it, and I'm proud of it. And will it work? We don't know, but that will be the core of like the gesture recognizer at the heart of my project in the final implementation. Let's see, what else do I have to show you? I've built like small tools as well for like data augmentation, just to take in a whole folder of images, flip them, and then output them again in that flipped state. Extract gesture picture. This is just for interfacing with the webcam, and then pulling out images and saving them in folders, because I've been generating my own data sets to determine like, is this a fist, is this an open hand, and so just helper libraries for that. I can show you my lab book. So yeah, we got to keep detailed lab books for this project, and mine is already 99 pages long, and it's only the 31st of August, so I'm pretty sure it's going to be damn monstrous by the time project's finished. But yeah, we just have to keep like a detailed history of what we've been working on, and all the different prototypes and things we've tried to get our projects working. And basically, I have done a lot of small implementations and prototypes recently that I haven't mentioned to you. Things like trying to classify the coordinates of different parts of a hand based on a delta value from a central point. And basically then every pixel in the image has a delta value from the set point in the middle of the hand. But then those delta values didn't work. Oh, where is that? That's quite cool to show you actually. Yeah, like this heat map here shows you that where the hand, this is my training data that I created. This shows you where the hand is expected to be, and as you get away from the hand, the neural network, the neuron value should be closer to 0 as opposed to 1 where the hand is, but it didn't really work. CNNs are not great actually, as I've now learned, for learning positional relative data like that. Much better at classifying. So yeah, that was just a whole system and a whole like day of work that just didn't contribute to the final implementation. But that's how you learn, I guess. And other things like going through how the hand tracker works, the OpenCV different implementations of the OpenGL stuff that I've tried, some of the different masking and the different pre-processing that I've done. This is what the YCBR color space segmentation actually looks like. So you can see it's just segmenting my face and my hand from the noisy background, because that's the only thing that falls into that skin color range. So very useful things that I've learned here. There's some edge detection, trying out different color spaces to see what works, different algorithm attempts, lots of text, lots of writing, segmentation approaches, OpenGL Cube. Yeah, it's been a long lab book, and that's like a little gesture recognizer that I built. So you can see, like, I built lots that is not going to go into the final implementation, but that will hopefully net me good marks at the end of the semester, and at the end of the year actually, if my specifications aren't met fully for the project. Because apparently the default kind of result for project, if you don't meet your specifications, is a fail. But then you have to talk about your engineering process and why certain things work and certain things don't, and why they don't work, and what you could do in the future to get them working. And the lab book is like the process of documenting that process, and so will hopefully be very useful alongside my final report in demonstrating the work done towards achieving the engineering goal of real-time hand gesture control of a virtual object in augmented reality. That's a mouthful. If you can't tell, I am very tired. Need to get out from underneath these fluorescent lights. But yeah, I've been here all day because it's productive to be in here, and this week, because it's end week, it's very quiet, and I found it productive to be here and to work. But yeah, I'm gonna get back to some little bit of code before I leave for today. Thanks for watching this video. I'm really looking forward to getting this project working, and obviously like moving on from it, but just, you know, getting a final finished working implementation and using that to kind of show off all the years of work I've done for this degree and have a nice culmination in my final year project. So yeah, I'll make another video in future soon when I've got some more stuff working, and definitely make a video at the end of the project going over the whole process and what it was like and how it turned out at the very end with my report and demonstration. But yeah, thanks for watching. The labs are nice and quiet today. I'm actually the only person in my row. There's some other people around busy working, but yeah, it's end week, so we don't actually have to be here. But thanks for watching. I will see you soon. I'm so tired.